Hi, welcome. So I have a question from a student, Ayut Ghosh, and he has asked that what is the role of IDEs and microheater when used both in fabrication of a particular device, and the temperature of microheater can reach depends on what factors. That is his question. So you see, guys, we have seen how to fabricate microheater, right? And then we have a interdigitated electrodes in between microheater and an interdigital electrodes. There was an insulator. Now where can we apply, like what's the role of IDs? The role of IDs or interdigital electrode is to understand the impedance or measure the impedance, or in another way it can measure resistance. Now when impedance you can use and when resistance you can use, we have already discussed in lectures, right? So for example, if you put a tissue on IDE and on the tissue you have a PBS, which is a phosphobuffer sealant, then you cannot just measure resistance, you have to measure impedance. So that's a role of interdigital electrodes, which are the electrodes, right, used for measuring the impedance of the tissue. Now what's the role of heater and why we are using heater, right? So the heater is integrated on the chip with a purpose that we have to keep the tissue alive. Now tissue consists of what? It consists of cells, right? And what are we consist of? We consist of cells, then tissues and organs. So what is body temperature? Our body temperature is 37 degrees centigrade. So if I want to keep the cell alive, I have to have 37 degrees centigrade temperature. So how to achieve the 37 degrees centigrade temperature is with the help of a microheater. That's the role of a microheater. So I hope that this question is answered, and it also says it depends on what factors, like what is how temperature of a microheater depends on what factors. So microheater, since we are using a metal, right, when you increase the so far with the metal what we are developing, we are fabricating a resistor, and if you apply a voltage to a resistor, what will happen? Current will flow. So depends on what is the design of a resistor, what is the thickness of the metal, right? Because finally when you say resistor, and if you go down to a very basic formula for resistor, is nothing but R equals to rho L by A. It depends on the length, depends on the area, depends on the resistivity. Resistivity depends on the metal that you select, right? So that is the answer for that particular question. Then I have another question from Abdul Qayyum Mija. Abdul Qayyum Mia, and he has asked that I am very much interested for sensing VOCs in our Excel breath for medical application. But as if now selectivity as well as the low concentration of VOCs in our breaths is a big problem. So how can we improve the selectivity of sensors as well as it can sense very low concentration? So his question is, how can we improve sensitivity and selectivity of the sensors, right? So the sensitivity of the sensors, if we go for a thin metal oxide semiconductor materials, and if you go for nanostructured metal oxide semiconductor materials, then your surface to volume ratio increases. By increasing surface to volume ratio, you can increase the sensitivity. That's a answer for the first question. While you talk about the selectivity of sensors depends on several factors. One of the factor is, if you see the literature, temperature. At different temperature, the same sensor is selective to a particular VOC, or it is more sensitive particular VOC. But in presence of several VOCs, a same sensor cannot delineate all the VOCs. So what we have to do? We have to use sensor in array. That means there should be more than one sensors. And once you collect the data from those sensors, we have to use what is called artificial neural network, or algorithm that you need to develop to delineate those particular VOC that we are of our interest from the set of VOCs that we set of VOCs that are present in the breath. So Abdul, to your question, we can improve sensitivity by using metal oxide nanostructure materials, and we can improve selectivity by using array of sensors and integrating it with ANN. So I hope that my answer is convincing enough for you. If you still have a question, please ask me through the forum available. There is another interesting question by Safna, and the question is, what are the futuristic development and application of MEMS-based sensor from clinical perspective? Now, uh, it is little bit surprising because whatever I am teaching you in this course are all futuristic development of these sensors and MEMS-based devices. Like I said, most of the work that we have discussed in this particular series are research oriented work, so you will not find this work like in some textbooks, right? This is an actual application where you can use MEMS from the point of care device point of view, or from a futuristic application point of view, where you are talking about understanding the understanding the cancer and pre-malignant and malignant regions just by taking the image, right? Or you're talking about a device that can understand the antibiotic resistance just in matter of hours instead of 24 to 48 hours, which is a gold standard. So you see that these devices are not in market, but these devices have a translational value. That's what I mean by futuristic application of MEMS. Other than that, there is something called minimally invasive surgery, where we can use a sensor which is made up of material that can get dissolved within the body. It is called bioresorbable sensors. And the material that we use, like I said, it is something that our body can absorb. And that's why it's called bioresorbable. So what is application, for example, and how it can be futuristic? So a person, let's say a person is having a cancer, and there is a tissue, all right? So on the tissue, if we can just place this sensor, right, and the sensor has two wires, connecting wires, and then you have a transmitter, a wireless transmitter, and you have a receiver, you have an electronic module on which you can understand the tissue properties. What's the thickness of tissue? What is the size of the tissue, right? And if a patient is going through a particular therapy, if the tissue size reduces, you can see that result on the app. So this change in the tissue property you can measure with the help of the sensor that you have placed on the tissue with the help of minimally invasive surgery. So now you don't have to take out the sensor back, it will dissolve within your body, right, or within a patient's body. So that will be a futuristic point of application, or futuristic application of our MEMS-based sensors. So I hope that I have answered your question. If you still have questions, like I said, please feel free to ask me to the forum. One request I want to make to all the students who are watching today: ask questions that you have in your mind. Don't ask because you are forced to ask questions, all right? That is not something that you should anytime follow in your life. It is not correct, right? You should ask questions when you feel like asking questions, not because somebody is asking you to ask questions. So that one point I want to make it clear. And I hope that you have these genuine questions. If you have genuine questions that you are stuck, I'm very happy to help you out. Now, there is a
question from Pradeep Narayan. Why CHF3 in ion etching? Why not others?
Okay. Yeah, sure. So you can use multiple gases when you use the DRI process. This is about the DRI, is it? Yeah. So yeah. So yeah. So in DRI, you see there are two gases that are used. One gas is used for as a surfactant to help protect your surfaces. Another gas is used for etching the surface. So for example, you want to etch silicon. So if based on the material that you want to etch, you have to change the gas. So it's not right why this particular gas. That gas is, if you see the chemical reaction, that chemical reaction, for that chemical reaction, for etching that silicon, you have to use a particular gas. So when we go for DRI, have we already discussed DRI in this class? Okay. So if you want, I can again discuss to help you out how the DRI process works. So it etches, it bombards, the atoms are sputtered, and you can dislodge the material from the surface. At the same time, you add another gas so that it protects the wall. So this goes on. One is a protection layer, second is the etching layer. So for that, you have to use different gases. I can give you a chemical formula in the following classes so that it will help you out. So let me take another question from Pramod. And Pramod Shinde, he is a faculty. He has asked that your lectures are very interesting. Whatever we have learned through your theory lecture, can it be possible to have hands-on training on the same at your labs? So yes, it is possible, but if I say yes to you, I have to say yes to 2000 other students, right? So you understand the difficulty of holding or saying yes to 2000 students. But since you are a faculty, there is something called QIP program, which is called Quality Improvement Program, in which I tend to ask all the students who have participated. These are all faculty members who participate here in IISc, and we have a experimental class where they are brought to this clean room and they are shown how the devices are fabricated. So not from silicon to the entire device, but in between few processes. So we are in process of conducting workshop in a later half of this year, or maybe already this is the second half of this year, so maybe next year early. And if you have time, do attend. If you come to Bangalore and you want to stop by for 1 or 2 minutes, or maybe 5 minutes, 10 minutes, then I can give you a quick tour of the laboratory. However, when you say hands-on, it takes time. It takes time to understand fabrication. It may look very simple when you see the lectures, but when you fabricate, it is different. So that is another thing that you need to take care.
There is a question from Himanshu. What is difference between a CMOS based MEMS sensors and MEMS sensors we are learning in this program?
Oh, there is a way difference. This what we are learning here is not really CMOS based sensors. Okay, so our perspective. So you understand this thing. Our perspective is not to teach you a complex MEMS based devices. My my concern or my interest about teaching you this subject is to help you understand how you can fabricate sensors and then use it for medical applications. So that is a clear cut difference in understanding the CMOS based and MEMS based. We have not even talked about CMOS based sensors in this particular lecture series, and we will not be talking about that. So it is out of this present syllabus. But on the same note, if you want to understand, you can send me an email. I'll get you back on that working of CMOS based sensors. I have taken a lot of questions. I hope you don't mind. I need to answer questions which are related to our syllabus.
There is another question from Abdul. Can we do some characterization if I need for our research?
And he's from where? Okay.
Second.
Okay. So
person was asked the VOC question.
I see. Okay, yeah, Abdul. So I'm happy that you are online. You want to perform characterization. Now we don't have facility here in my laboratory to do characterization, but we have a central facility called Center for Nanoscience and Engineering. It's called SENSE. It is a facility in which you can. There is a program called INUP, in which the undergrads or the people who want to understand fabrication and characterization, they participate. So you can come through that program, or you need to contact a SENSE staff to help you out with the characterization techniques. Now, as far as the characterization tools are concerned, we have, when I say we, doesn't mean just my laboratory, it's an institute. Okay, so if it was in my laboratory and if you want to perform characterization of samples, now again, when you say characterization, what characterization? Because when you talk about a film, you can have atomic force microscopy, you can have scanning electron microscopy, you can have XRD, you can have EDEX. So everything has that own role. For example, you understand topography, right? Or you understand surface morphology. So if you want to understand how the structure of the film is, you can go for SEM. If you want to understand what are the crystal orientation, you go for XRD. Right. If you want to know what is the surface roughness of the film, you go for AFM, atomic force microscope. So what characterization you want? That is first question. Second question is, if there is one or two sample and you want to perform a characterization, I can help you out. But if it's a research study, then like I said, it will be better you contact the sense staff, and I'm sure that they will help you out. In any case, if you are unable to contact them, you can send me an email and I'll try to respond. Thank you.
There is another question from Dinesh. As we know that silicon dioxide thin film on silicon have a compressive stress, and volume expansion is 2.2, value is 2.2. If this means that if we select the material which has this value near to 1, then the thin film is stress free and straight?
No, it doesn't matter. The silicon dioxide will have its compressive stress, and to overcome that stress we are using silicon nitride. If you remember a structure, sorry, yeah, that's what I'm talking. Yeah, so it's a piezoresistive cantilever. When we had discussed, right, we had drawn the process flow, and in that process flow, if you have seen that when we don't use silicon nitride to compensate that stress, our silicon cantilever was having a band structure, right, compared to a straight one. So if you just go back to the lecture notes, you will see that. And thus just making it thin is not one way to remove stress, but people have opted different way. For example, if you anneal the film, the stress component can be reduced. When you sputter the film, what power, what pressure you are using, you have to optimize that power and pressure to reduce the stress. So that is one way of doing it. Just reducing thickness may not be only a solution. That will be my answer to your question. Yeah, so Ajay is asking what are the different types of wafer generation. So I'm not sure what you mean by wafer generation. There are two types of method to fabricate silicon, like to develop a silicon wafer, right? One is Zukralski technique, one is float zone technique. In terms of generation, I really don't understand the question, but in terms of type, I can say it's 100, 111, 110. This is based on the crystal orientation. In terms of extrinsic and intrinsic semiconductors, if the silicon is doped, then it is extrinsic, not doped, intrinsic. In terms of the type, it can be P type, N type. And I think that I have taught you, depending on the secondary flat with respect to primary flat, how you can understand or differentiate between P type 100, N type 100, P type 111, N type 111, right? And that is depending on whether it is 45 degree, 90 degree, 180 degree. So when I'm saying 45, 90 and 180, this is respect to the secondary flat with respect to the primary flat. That's what I talked about the thing. So I think that's what your question is. If not, I'm really sorry, I don't understand your question. You can elaborate and you can send me an email or you can ask in the forum. I'll be very happy to answer your question. Anything else? Let me see. Yeah, what one student, Dibiga, see what is the future of MEMS compared with NAMS? So you see, you should not compare. Both technologies are different, right? MEMS is different, NAMS is different. And each of those technology has their own application. For example, you see now what I am teaching you. I'm teaching you MEMS-based sensors, right? And if you see from the application point of view, the from clinical perspective point of view or from medical perspective point of view, you see that none of the devices that we have discussed are existing in market, and there is a huge market for translating these devices, right? So MEMS itself is really important. When you talk about NAMS, that is specific for certain applications, right? So there can be a nanostructure material on the microstructure material, and you can say it's a nanotechnology. We are integrated with MEMS technology, but you cannot or you should not compare MEMS and MEMS both together. So I think that is one thing that I will tell you. You cannot or you should not compare MEMS with NEMS. And how is MEMS similar to biomimicry? Uh, I really don't understand what you mean by biomimicry. I'm sorry about that. But what I understand is if you say about biosensors or sensors that that are used to understand the biosignals or measure biosignals. So MEMS, when you talk about MEMS-based sensors, you have to understand that it is a micro electromechanical system. So it is a MEMS sensor. If it's a MEMS sensor, there should be a mechanical component, there should be electrical component, electronic component embedded onto the system. We are talking about MEMS based. That means that we are either using micro machining, maybe dry etching, maybe wet etching, maybe deposition. So part of the MEMS we are using, MEMS technology we are using to fabricate the sensor. So that's what I said. When you talk about biosensor, right, you can just deposit a film, and on that film you can directly deposit two electrodes, or you can just take a contact from the film. That's what a biosensor would be. I don't understand what you mean by biomimicry. So if you can elaborate that question, I can help you out. I can answer the question in much more detail.
There is a question from Himanshu.
Hmm.
How one can find the recent research topics based on this paper?
So that's interesting question, and I'm very happy that you want to find research topics. So the only way to find is to read, right? You have to read literatures available in the net. So again, when you say just MEMS, what you will do with MEMS, right? So since my area of interest is to apply the MEMS for clinical studies, that's why what I teach or what I am teaching in this particular course or lecture is how you can use MEMS for clinical applications. That's why I try to read papers from several journals. You can take STM, which is one of the best journal in science. It's called Science Translation Medicine. You can go for Nature Communication, Nature Biomedical Engineering. You can go for Lab on a Chip. You can go for IEEE Transactions of Biomedical Engineering. You go for Sensor Actuators B. You can go for Biosensor Bioelectronics, right? And there is IEEE Sensors, IEEE JMEMS, and lot of journals, right? So what I would first request you is first find the topic that you want to work on. Once you find your topic that you want to work on, let's say you want to use this MEMS-based sensors for understanding the let's say a protein in your sample. All right. So now, since you want to understand a protein in your sample, which protein and how this protein is related to the disease that you want to diagnose. So you should start understanding from that particular point and start downloading research papers. The more you read, the more you get the ideas. There is no way that we sleep in night and in morning we have ideas. Of course, that happens sometime, but you have to cross-check whether already somebody has done that work or not. When you read a lot of papers, you will get a lot of ideas. And another way is to talk to your seniors, to professors who are working in this field. Once you select your application, all right, and uh, that is the best way to learn. Books will help you out, but books will not give you the ideas. They will give you knowledge. They'll give you understanding about the topic, but how to use this topic for a particular application, that you can only understand or try to understand or try to generate when you read the research papers. Right? So that will be something that you have to understand. Uh, yeah. So we have one more question from Suganthi S, and the question is non-invasive techniques other than those using VOC sensors. Okay. How about you have a temperature sensor? Have you seen a temperature measurement gun? Right. If you see it, it is non-invasive, but it can measure temperature. No, there are sensors that are based on IR. and based on that, we can understand the tissue properties. There is something called eye breast scan. If I remember correctly, it's called eye dot. So eye is eye, and breast scan. So if you see that research work, you will see how for non-invasive technique can potentially be used for understanding or for diagnosing breast cancer. So yes, there are non-invasive techniques that you can use for that applications as well, other than VOC sensors. So that's the answer for you. Let me see if there is another question. Yeah, I think Sharayana Krishnamurthy. Sir, could you please suggest in general how we can go about designing a MEMS-based device to solve a specific problem statement? Yes. So the best way is to first how can we go about designing a MEMS-based device to solve a specific problem statement? Okay. So okay, let's see that like this. Suppose you want to understand the stiffness of a material. Now, how can you measure stiffness? You want to design a MEMS-based device, isn't it? So for understanding stiffness, you have to press the material. If you want to press the material, what should you have? You should have a pressure sensor. Right? Now, how can you design a pressure sensor? So either you make a cantilever, fabricate cantilever, or you use a piezoresistive material on a diaphragm and place the material on that and press it with an indenter, right? So if you know the application, you can design. Now, like I said earlier, the more you read, the more you get. When you design something, before you fabricate, there is a process called simulation. So try to at least go for simulation, understand simulation studies. There are a lot of software available for performing MEMS-based simulation. One or two such software can be ANSYS, and another one we can use is a COMSOL multiphysics. So you can use either of those. There is one called IntelliSuite that's also used heavily for the designing of the sensor. So you can use any one that you want. But for particularly for simulation aspect, COMSOL and the ANSYS are used, while for designing IntelliSuite is used. So that will be the answer to your question.
There is a question from Himanshu.
Mm-hmm.
It is a request. Please introduce any of MEMS sensor with simulation and analysis using some software like on COMSYS multiphysics. It will be a great help.
Okay, how much time we have in the total lectures? How much we have recorded? We have some time?
We have finished complete the class.
Okay. See, the course is of 30 hours. So I'll try. All right. I'll try to show you one such application where we are using COMSOL multiphysics or ANSYS to perform simulation. Right. So let us keep it as a experimental class. So we can show them a heater. Yeah. So we'll show them a heater. We'll design a heater, and on applying different voltage, what is a change in temperature, so that we can go for one class. So no problem about that. Okay. But always understand we have 30 hours. But I'll be very happy to acknowledge your query, and I will introduce this topic in the current syllabus.
There is a question from Abdul. I want to detect stomach and lung related cancer by analyzing VOCs in exhale breath. But my difficulties is to finding the VOCs corresponding their diseases. Can you suggest some journal or paper?
Send me an email and I'll respond to you. Right? See, when you talk about when I talked about diabetes, it is known. Literatures are available. You talk about lung cancer, for example, there is NO2. Along with NO2, there are several other VOCs, several other gases. Same thing if you want to understand liver or stomach cancer, you need to understand what VOCs are generated. So I need to go back and see the literature and then only I can respond. I don't have something on top of my mind that these are VOCs available. I hope I could remember all the VOCs, and then I can use my eNose application for a lot of other VOCs. But yes, in all seriousness, you send me an email without forgetting this thing, and please ask me a question. I'll respond back to you for sure. Yeah, for now, I don't know what VOCs are there or what papers you can use. Like I said, the sensor actuators B would be one of the nicest paper to see. There's a IEEE biomedical engineering articles are there. You can go further. There is a special journal on diabetes. So what I'll do is I'll send you the details of those journals along with some publications that are relevant to your question. But like I said, once you send me an email, and depending on how I find time, I'll respond to you, but I'll respond for sure. That is one thing like I can promise. I don't know when, but soon. Once I receive the email, probably in within next 7 days, I can respond. Okay, so there is one question from Shobha Gupta. She is a faculty, and the question is how to measure impedance of malignant tissues slash cell in frequency spectrum, and what parameters need to be considered while modeling and fabrication. Now, for understanding whether tissue is malignant or not, you should have tissues which are normal, no? So without control, you cannot do any experiment. All right. So what I would suggest is you can use a frequency spectrum from 0 to 2 megahertz. You have an entire sweep, and you can use 10 millivolt as a DC voltage. You can use a frequency analyzer, impedance measurement analyzer, and you place your normal tissue on the interdigital electrode, and then you place your malignant tissue or interdigital electrode and see at what frequency you can see the maximum change, maximum difference in terms of impedance. That frequency will be your frequency at which you have to measure the tissue impedance. If you see one of my paper where I have tried to understand the change in the tissue or change in the electrical property based on the tissue that we place on the sensor, to understand what are the modeling that we can do and how we can understand the impedance measurement. So but one thing is like how you know it is malignant and how you know it is normal. So you have to have a good collaboration with a oncopathologist where they do the gold standard for you, and they can tell whether the tissue is normal or whether tissue is benign or whether tissue is malignant. Again, what kind of malignancy you are looking at, whether looking at the ductal carcinoma or you're looking at the invasive ductal carcinoma. So if it is a breast cancer, if it is a oral cancer, it's different. If it's a lung cancer, it is different. So like I said, you cannot just take the tissue and say it is cancer. You have to have a cross check with a gold standard, and gold standard is histopathology followed by the biomarkers that we obtain. So that's why a good collaboration with a oncopathologist and a clinician is very important to get the tissue sample. If you already have a tissue sample, you can fabricate interdigital electrodes, place the sample. Again, before you place the sample, it will be better if you can fabricate a SU8 well. So your interdigital electrodes are there on which there are SU8 well, in which you can place the tissue, and then you have to place PBS, right? Because you have to maintain your tissue, it should not die, and then you apply the frequency sweep and see the change, right? So that is one way of doing it.
There is a question from Himanshu. What will be the minimum requirement if one wishes to pursue some research work under your supervision or guidance?
You should be a good human being. That is a minimum requirement, right? And I'm very serious about that. You can be an excellent engineer and scientist, but if you're not a good human being, I would not like to work with you. And I very strongly believe there is no under and over. It is when we are to work, we have to work with each other, right? So but I really appreciate your thought that you want to work with us uh, in uh, in this area. uh, what generally I look after my first criteria of being a nice person, nice human, is whether you have worked in the area of microfabrication or what new expertise you bring to the laboratory, something that we don't know, right? And that will be a add-on thing that we want to get from a student. At the same time, your engineering skills should be good. You should be good in one, and you should know a lot of subjects, but you should be super in one, right? So you tell us you're good in robotics and you want to work, we'll find an application where you can use robotics for biomedical engineering, right? You tell me that okay, you are really good in simulation, and I'll help you to understand the fabrication. Having said that, there are certain rules and regulations formulated by IISc. You please visit the website and see those rules. If you fall within that laid rules, you can always apply when there is a vacancy, right? So, but thank you once again for your interest. I hope we can work sometime on interesting research problem. Yeah, there is a Aratrika Mukherjee. I'm sorry if I'm not pronouncing it correctly, but the question is book suggestions. I'll give a list of books. No problem about that, right? I don't want to just tell it to you in live session. I'll just show you in one of the lectures so that everyone can get the uh, access to those books, hopefully. But more than books, what I feel is what I'm teaching is how to apply the things that are in books in a real life, and that's why the clinical perspective, right? I'm sure that this thing that what we are teaching, uh, the application point of view, or device point of view, the application of the device for clinical applications, you will not find in books. You will not find. What you can find is how microfabrication techniques are there, what are the chemicals used, uh, and some applications. So, but for the general interest of students, I'll just give you a list of books in my next few lectures. You will see one lecture where you have list of books. In fact, is there any way that we can send to all? Yeah, okay. We will do that announcement thing, and we'll give you a list of books.
There is a question from Dinesh.
Hmm.
So that is also related to what Himanshu asked. What about postdoc?
Sure. Dinesh has PhD. Yeah. So, Dinesh, I hope you have a PhD. And if you have a PhD, that is a SERB postdoc fellowship. There is another interesting fellowship recently announced in IISc, and that is on more on brain research. So, if you're interested in working in the area of brain computing or let's say understanding the EEG signal or designing a system for measuring EEG signal, so anything related to the brain research, and IISc recently had announced two postdoc. I am, if I'm not wrong, and it's just a good way of getting it. Again, the second way is SERB postdoc fellowship. The third way is there are IYBA that was recently announced. So Indian Young Biotechnologist Award or Institute of Biotechnologist Award. It's an Indian Young, yeah. So there are two PhD students, they already applied, and if they get it, then they can join the lab. You have to find a mentor, and just don't find someone because he or she is ready. You should find that it should match your interest, right? It's very important with whom we work. Both persons should be happy. If you want to work with an X person, that X person should have some kind of expertise, some kind of interest to in the area you want to work in, right? And I'm sure you know these things. I'm just uh, helping you out, maybe if you don't know. So three things again: IYBA, SERB postdoc fellowship. You can always contact to supervisors. In some of the grants we have or funding we have from government, we put this postdoc as a manpower. So some professors may have that particular position available with their group, but how you would know? That is, once you identify your interest and you contact the professor, then only you will know. In fact, in the SERB postdoc fellowship and other fellowships, you have to write which institute, who will be mentor, right? What is his area or her area of expertise? So there are details. I have one postdoc with me in my lab, and like I said, there were two PhD holders, one from IIT Bombay and another one. So she's from Bangalore. So they have applied for this IYBA. So I'm just waiting for the result.
So Dinesh has just added that he's doing his PhD in MIT and he's planning to do wishing to do postdoc under your guidance, and he's working on heavy metal detection in water.
Good. I wish you all the best for your PhD. If you are in last year of your PhD and everything is done, then I would suggest you to apply for postdoc applications, like as many as you can. Finding a proper proposals or project, and then as many as you can. Okay, so when you're done, we'll see. But by the time you're done, you should have a postdoc position in your hand. That is a best thing a student can have. By the end of their PhD, they should have at least one or two offers to think about, right? So we'll see once you are at the end of your PhD. No promises. I don't commit. I don't promise. Don't believe that. Just work and you will achieve something.
There is a question from Pradeep Narayanan. How about a collaborative work in the research of MEMS?
Sure, I'm very happy to collaborate. If you have an interesting problem, very happy to collaborate. No problem at all. But like I said, interesting, I'm stressing the word interesting. Right? So you better have an interesting problem. Or you to get me a lunch. I'm just kidding. So yeah, always look for a healthy collaboration, not just one-sided work. One-sided relation in life also doesn't work, right? So it should be for both. So you bring a nice topic. Let me know what is your lab expertise and how can we help you in terms of collaboration. Earlier, I collaborated with few faculty from engineering colleges, and it was interesting. So I really believe in strong and healthy collaboration. No problem at all.
And again, he asked a question: what protocols mainly accept interesting problems?
No protocols except interesting problems. You see, if you have a project, right, and you want to fabricate a sensor, for example, and you say that, Hardik, I want to fabricate a sensor, but I don't have the facility. I can help you to fabricate, but again, you understand that for fabrication, we require a set of funding that we need to pay to use the equipment. So that will be only constrained, what I feel. But if you want to take help in terms of simulation, design, or you have an idea on which you want to work together and see whether we can come up with an interesting proposal, I'm very happy to that. So other than interesting project, but you see, why to not work on interesting things? I think you meant that interesting is there, along with interesting what other things. So along with interesting, I think if it is for fabrication, again, fabrication is just not like because you have written somewhere, fabricate a device, I'm going to fabricate. What is application of that? Is it really cool? Because we fabricate a lot of devices, but what next? So next step, are you going to apply it somewhere? And having said that, it is better to send an email across and have a Skype call where you discuss with me, and we can think about the future collaboration. So I think that is a way to go for.
So Abdul has just added that I have really become your fan. The way you are teaching and the application of semiconductor in medical applications, that common people effort. Thank you.
Thank you so much, Abdul.
Pradeep Narayanan has added,
Mhm.
I will approach in person in email with detailed steps from the beginning to the end use of the products.
No problem at all. Like I said, you don't have to really tell me the details, but you are welcome to do so, Pradeep. You can find my details, contact number from the website, and give me a call or WhatsApp me and say, okay, Hardik, I'm Pradeep, and I want to discuss a interesting project, and we can go on from that. I will very happy to see what you have in mind.
There is a question from Chilveri Naveen. Good evening, sir. To join PhD in MEMS, as per exam and interviews, as well as professors' expectations, how to be ready for that moment?
See, for like I said earlier, there are rules and regulations that IISc has laid down. You need to understand, and then you understand what are the department rules for getting into a PhD uh, mode. So, for a BTech candidate, we require GATE. For MTech candidate, we don't require GATE. Of course, MTech with GATE is also preferable, but it's not mandatory. So the point is, after saying that, there are cutoffs, and that is every time it is different based on number of applications that we receive. So I cannot tell that with a particular gate score and particular MTech score, or your 10th, 12th, and your undergraduate score, you can be called for the interview. But if you qualify for the interview, then what we see is your expertise in mathematics, because for engineering PhD and for most of the PhDs, we require a good math. That is the basic. And then you need to select the area in which you want to work. So for my department, I can say that we have 4 or 5 different groups, and you can select one of the group at the time of your uh, interview. Suppose you want to work in power electronics, or you want to work in semiconductor devices, or you want to work in micro fabrication and biomedical application, or neuronics. Or you want to work on memories, or you want to work on communication. So we have groups, we have faculty members with expertise in those areas, and just before your so you have to keep on checking the website, right? That is a best way to come. Along with that, you can always contact a professor. Always contact a professor. There is no problem in contacting a professor and understanding how his work or her work is appropriate to your interest and why you want to join a particular group. So that is not to get you admission, that is just to help you out, that okay, if you get an admission, this 2 3 4 people, you want to work with those people, right? But that comes at a later stage. First stage is you have to clear your interview. So for PhD, we don't have any written test, at least for our department. For MTech we have, and everything, like I said, it is already there in the website. So that's a way in. I just hope that what you wish you get. All right, so I think if we don't have, or if you don't have any questions, then we will stop here, and there will be one more live session like this sometime later at the end of the course, so that if you have any more questions you can ask. However, I prefer that you have the forum to ask, so ask through forum. Again, let me reiterate that the question should not be asked because somebody is forcing you. I'm sure nobody is forcing you, but it should not because your friend said, I asked 2 questions, so you should compete and say, I asked 3 questions. That is not a way to use the forum. Forum is where you are stuck, right? So you don't have to really worry about your marks or certificate is based on questions that you ask in the forum. Let me very assure you this thing. Your marks or certificate in this program is based on how well you do in your assignments, homework, the quiz, or your final exam. It is nothing to do with your asking questions in forum. Forum is meant where you are really stuck with a problem, right? So I hope you have very clear message from a faculty who is taking this program. So I'm assuring you once again that don't worry about asking 10 different questions. Ask a question which is genuine, which makes sense. Again, it will be difficult for answering that how can I get into PhD, right, in a forum, because that has nothing to do with my course. You can always, I'm stressing on it, please send me an email. I'll be very happy to answer your email if it makes sense. Then okay, procedure, right? A general procedure is in ISC website, a general procedure is in DESC website. But if you are still stuck, please feel free to ask questions. Just don't compete in asking questions. There is no competition. Just compete with yourself. That's what I will stress. So
One last question
sure.
from Pradeep Narayanan.
Okay.
How about MEMS usage in lithium-ion batteries? Do you have any idea?
No, I don't have any idea about use of MEMS in lithium-ion batteries. So I think this is little bit off topic from my research area. So unfortunately, I cannot answer your question. But yeah, if you show me details and if there is some MEMS component that is required, we can discuss and get back to you. But yes, I have not worked on lithium-ion batteries in my research career. Okay, so I think if you don't have any more questions, I'll wish you all the luck for the remaining part of this course. I hope that you get few ideas and at least understanding of how you can use the microfabrication in general and use it for the clinical perspective, clinical applications. All right. So, you have any questions, or we should?
Yeah, one question.
Sure.
We do have a mask aligner at our lab. Can it possible for me to join any hands-on training at your institute? By Pramod Shinde.
No. You can, of course, have a training schedule in sense, and that is only for students, my institute students. Now, at some point, if I have a mask calendar in my laboratory, and if you want to learn at that time, you can request us. I will ask my PhD student to help you out. But right now, I don't have. So when I will have is again a question. So hopefully in next 3 months, that is the quickest where I see a mask calendar in my laboratory. Other than that, there is an INUP program, like I said, and you can come here and you can understand how the mask calendar works. I'm not too sure whether they give you access to a mask calendar or not. Hopefully they will show it to you. So unfortunately, right now, I cannot help you. Maybe in next 3 months, after 3 months, please do contact me. All right. So thank you guys. Have fun.